Hello dear students, welcome to ECE Academy Benefactor. The topic of the class is encoder. In this class we will be seeing the definition of an encoder, its general structure and how to draw octal to binary encoder, its logic diagram. So, let us see the definition of an encoder. Encoder is a combinational logic circuit. This topic is from combinational logic circuit unit and the subject name is digital electronics. So, what is an encoder? Encoder is a combinational logic circuit which is having 2 to the power n inputs and n outputs. So, how do we denote a encoder? 2 to the power n is to n. It means that it is having 2 to the power of n inputs and n output lines. So, it is drawn here 2 to the power n data inputs and n data outputs. To enable an encoder, we must connect an enable pin. En stands for enable. So, it is written as an encoder has 2 to the power n input lines and n output lines. Coming to octal to binary encoder. So, you know how to draw a combinational circuit logic diagram. So, first we should know the truth table. So, let us see the octal to binary encoder. It means it is a code converter which is converting octal to binary. So, octal means how many inputs it will have. So, truth table is having inputs and outputs. Octal, input is octal. Octal means D0 to D7 bits. Octal means D0 to D7. To binary, it is octal to binary. So, each octal number is having 3 binary bits. So, output is 3 bits A, B, C. So, here written D0 as 1 and all other inputs are 0. So, when D0 is 1, what is the binary? D0 is 1 means the binary will be 000, that means it is a 0, 0, 0, 0. If D1 is 1 and all other inputs are 0, D1 is 1 means the output will be 1, 0, 0, 1. D2 is 1, all other inputs are 0, D2 is 1 means binary will be 2, 0, 1, 0. D3 is 1, all other inputs are 0, D3 means 3, 0, 1, 1. D4 1, D4 means 1, 0, D5 is 1 and all other inputs are 0. So, what does it mean? 1, 0, 1. If D6 is 1, all other inputs are zeros, D6 is 1, the output will be 1, 1, 0. If D7 is 1, the output will be 111. So, if you carefully see, these numbers are 0, 0, 0, 0, 0, 1. How they are appearing? Depending on which input is high. If D3 is high, what will be the output? 0, 1, 1. So, important note is here while drawing this truth table. In this octal to binary encoder, in encoder it is assumed that only one input has a value of 1 at any given time, otherwise the circuit is meaningless. So, here if you carefully observe, here only one input is set as 1 for octal to binary encoder. If we will have 2 inputs, then it will be meaningless. So, while designing octal to binary encoder, we have assumed that only one input is going to be high and all other inputs will be low or 0. So, if D0 is 1, all other inputs are zeros, the output will be 0, 0, 0. If D7 is 1, then output will be 1, 1, 1. Okay. So, now we have to write the equation of A, B and C outputs. For A output, so we will see where they are 1. So it is 1 at D4, D5, D6 and D7. So we can write the equation of A as D4 plus D5 plus D6 plus D7. Okay, D4 plus D5 plus D6 plus D7. B, writing the B equation, we need to see where it is 1. So it is 1 at D2, D3, D6 and D7. So it is high at D2, D3, D6, D7. So it is written as B is equal to D2 plus D3 plus D6 plus D7. C, let us see where it is high at D1, D3, D5 and D7. So D3 is high at D1 plus D3 plus D5 plus D7. So these are the equations. Now based on these Boolean expressions, we need to draw the logic diagram. So this is the logic diagram of octal to binary. We have drawn the inputs from D0 to D7. D7 input, D6, D5, D4, D3, D2, D1, D0. We have drawn like this. Now to get A, what we have to do? We have to take D4 input, darken this D4. D4 plus D5 plus D6 plus D7. So we have taken the inputs from D4, D5, D6 and gave to an OR gate to get the expression for A. A is equal to D4 plus D5 plus D6 plus D7. And B algebraic expression is coming to, Boolean expression is coming to be as B is equal to D2 plus D3 plus D6 plus D7. Boolean expression D2, D3, D6 and D7. So D2, D3, D6, D7 are given to an OR gate to get B output. Now to get the C output, we need to take D1, D3, D5 and D7. We need to darken these inputs D2, D1, D3, D5, D7. We need to darken these points so that it indicates that the input is connected to D1. If you are not darkening, it means there will be ambiguity whether you are connected to D0 or D1. If you darken, it is clear that the input is coming from D1, then from D3, then from D5, then from D7. D1, D3, D5, D7 are given to an OR gate to generate the C output. So this is the octal to binary logic diagram. Okay. So here there are few points to understand. The above circuit has one ambiguity. When all the inputs are ones, when all the inputs are 0, the outputs are 0. When all the inputs are 0, what will be the output? When there is no input, will there be any output? No. So the above circuit has one ambiguity. When all the inputs are 0, the outputs are 0. The second condition is when D0 is 1, the output is also all zeros. This ambiguity can be reduced by an additional output that specifies the valid condition. So this is a limitation of this octal to binary circuit. So when D0 is 1, all the outputs are 0, and if the second condition is when all the inputs are 0, what will be the output? Obviously it will also be 0. So there is a slight ambiguity here. So this is the limitation of octal to binary encoder, or else the other things I hope it is clear. So when D0 is 1, output will be 000. When D3 is 1, the output will be 011. When the input D5 is high, the output will be 1 0 1. When D7 is high and all other inputs are low, it will be 1 1 1. So based on this we have written A expression, B expression and C, and has drawn this logic diagram. I hope you have understood the class. If you have any queries, you can post in the comment section. Thank you. Good luck, students.